In this video, we are going to learn how to save money when using AI models by using prompt caching. So we're going to learn what prompt caching is, what is explicit and implicit prompt caching, and also we're going to learn how to use those two techniques from a .NET application. So let's get started. First, what is prompt caching? Well, when we send a prompt to an AI server, for example, from Claude, from OpenAI, from Google, etc., that prompt has to be processed. And that process costs money. Therefore, what if we send the same prompt twice? Well, it would be great if the server remembered the result of that processing. In that way, we don't have to incur on the cost of re-evaluating that prompt, and therefore, we could save money. Well, that is prompt caching, the idea of remembering or caching the result of processing a prompt. Now, not every prompt is going to be the same, so we can divide a prompt in chunks, right? We can have a first part that is static and then a second part that is dynamic. So that first part is going to be put in a cache, and therefore we don't have to reprocess that part of the prompt in the server, and so we're going to end up saving money. And this is something that is documented on the different AI models. For example, let's go to the documentation of Luna. We are here in Luna, in the Luna documentation in OpenAI.com, and we can see that the cost of input is 0.20 per 1 million tokens. Now it says 0.20 here, but if it is cache input, if it is using prompt caching, it is going to cost 0.02, which means that that cost is divided by 10. So indeed, we're going to end up saving a lot of money if we take advantage of using cache inputs, that is, using prompt caching. So as we said before, the idea is that if you have a prompt, you can separate the static part and put it first. That is very important, you have to put it first. And then the second part of that prompt, which is the dynamic part, you put it in the end. And with that, you are going to end up saving money. And the reason for that is that there is two types of prompt caching, implicit and explicit. Implicit means that you are going to allow the server, for example in this case OpenAI servers, to do the caching for you. You don't have to indicate what part is static and what part is dynamic. Basically, the server is going to use technology, a heuristic, an algorithm to determine what parts should be cached and what parts should not be cached. And this is important because this distinction matters because writing into cache has a higher cost than simply using the model. That is, even though here it says that it is 0.20, writing into cache costs 1.25 times this, which if we take a calculator, if we quickly do this, times 1.25, that is 25 cents per million tokens. So we have to be careful when writing into cache. So what we're going to do next is to see this in action. Enough of see me talking. So we have this request here. As you can see, this is a request for the model Luna. Of course, we're using OpenAI, but this works the same in Claude. We have a role system, we have this content. Now, this is our static content, therefore I put it first. So we have all of this content, and then we have the variable part, which is this, which is the question of the user. So basically we have a system in which we have some text here, and we want to ask questions about that text. For example, can I cancel an order that has already shipped? That information is here. Alright, so the idea here is that if we press send, we're going to see, let's wait a moment. We're going to see that we have, yes, a response, but what I want to see is this. We have prompt tokens 1905, and we also have cache token 0 and cache write tokens 1902, which means that we're writing into cache 1902 tokens, which means that if I do basically the same prompt, I use the same prompt, let me minimize this, I use the same prompt, but only change the question that we have here, and let me do that right away. For example, let me ask this question, and if I press send, since the first part of the prompt stayed static, therefore, now we have that we're using cache tokens, which means that now that part of the prompt costs way less than it costs in the first prompt, that it costs in the first request. So indeed, we're using prompt caching because the static part is at the top of the prompt and the variable part is at the end. That is the question of the user, the dynamic part. Therefore, we're being efficient. Now, notice something. Notice that it says here that it is still writing in cache because we're using implicit caching. Notice that I'm not saying in any part of this request that this content is going to be static and therefore we want to save it into cache. No. We are using implicit caching because we are allowing OpenAI, in our case OpenAI, again the same works with Claude or Gemini or whatever, we are allowing them to determine what part is static, and therefore it does a pretty good job, but it's not perfect. If we want perfection, we have to use explicit prompt caching. With explicit prompt caching or just explicit caching, the idea is that we're going to say, for example, that this is going to be static and therefore this should be in cache, but this part that is variable, that is dynamic, it should not be included in the cache, and therefore we're not going to waste money writing something into cache that we're never going to use. So let's do that. In order to make this use explicit caching, we come here and we say, let me say here, prompt cache key. We can give it a prompt cache key, for example, user manual postman. We can do whatever string we want. And here, prompt cache options, mode explicit. So here we're saying that we're going to be using explicit caching. Now, I need to say, for example, in this case, that this is the static part, and therefore I want to include it into the cache. So let me introduce a breakpoint. The idea of a breakpoint is that this is going to be introduced into the cache, and everything after that will be outside of that cache. Therefore, this part will never be included into the cache. Let's see that. Let's press send. Since this is the first time that I execute this, nothing will be in cache already. Therefore, cache tokens is 0. Cache write is this. Okay, that is fine. Now, let me execute this a second time. So let me change this question, for example, to this one. Send, and you are going to see something. You are going to see that now it says here cache tokens, this amount of tokens, and cache write token 0, which is great because it means that we're not wasting any resources by writing something into cache that we don't need to have it in cache. Now, something that I forgot to mention before we move on to a .NET application to see how to do that in a .NET application is that when we're doing implicit caching, basically what it does is that it saves this string into the server and use it as a key. Therefore, if I were to change this when using implicit caching, if I were to change this, for example, this semicolon to a comma, just as an example, then we wouldn't have used cache tokens. Therefore, it is very important to realize that implicit prompt caching depends on the first part of the prompt staying the same. If you change anything, it could be a simple punctuation sign, then you wouldn't get the benefits of using prompt caching. Alright, so let's go to our .NET application. I have Visual Studio here. So basically, we have two versions, one with the SDK and another without the SDK. Now, this is important because, sadly, at the moment of recording this video, let me show you that I am using the OpenAI library version 2.12, and this one doesn't include the necessary mechanism for me to do explicit caching. I can only do implicit caching when using the SDK. Now, in order to use explicit caching, I have to use the HttpClient. Now, maybe in the future, in future versions of this package, we may have access to the possibility of using explicit caching. So this is why here I have two examples, one with the SDK and one without the SDK. So let's see the one with the SDK. Let's come here. As you can see, I am instantiating the OpenAI client. Of course, you can do the same with Claude, but in my case, I prefer to use OpenAI's. So here we have Luna. Here we have the system prompt. This is the same that we have here. But using the SDK. So we have a first request. We have this question. Then we build a prompt, which is going to consist of the system prompt and the user prompt request. And then we have here response. And we're going to write on the console the chat token usage. We're going to have prompt tokens and cache tokens. Now let's come back here. We are here in with the SDK, and then we have immediately a second request in which we're going to ask another question, but we're going to repeat the same system prompt. And notice that I am explicitly putting the system prompt first in the prompt history, and this is important because in this way we're going to take advantage of implicit prompt caching, and therefore we're going to save money. Alright, so then we do the request here and we write the token usage in the console. Now, let's go with the without the SDK. As I mentioned before, I needed to do it like this because here I can put the prompt cache key, the prompt cache options, and also the prompt cache breakpoint. So we have here that this system prompt is going to be static, and therefore we're going to be efficient because I am indicating that this is the only part that should be put in the cache. Since this is a breaking point, it means that everything after that is not going to be put in the cache. So this is dynamic content. Alright, and we have everything else here. So we use the HttpClient, we have here the URL, the bearer token, content, application JSON, here is the input, we do a post async, and of course, by the way, I forgot to mention that we have here the prompt, which comes as a parameter of this method. Alright, so then we get the value of the use tokens, so we have prompt tokens, cache tokens, and cache write tokens. The reason why, by the way, and we're almost running this, the reason why I don't have the tokens that were written in cache here is because that is not available in the SDK yet. Alright, so let's see that here we have, so with the SDK, we will have this, of course, with the SDK, with the SDK, and then without the SDK, first request, this is the prompt, we have an empty line, second request, and this second prompt. Alright, so let's see this. Control F5, and with this we're going to see how we can use prompt caching both implicit and explicit in a .NET application. Alright, so here we have this. With the SDK first request, we have prompt tokens 2004, cache token 0. In the second request, we are going to see that we have 2002, but in cache tokens, we have 1985, which means that we're being efficient here. And then here in without the SDK, we have first request, of course, 0 cache tokens, and cache write tokens, this amount. But then in the second request, we're being efficient because now we have something in cache, and therefore cache tokens the same number, and cache write tokens 0, and therefore we're being as efficient as possible using explicit caching. I hope that in the future they are going to add the ability to use explicit caching in the SDK, at least in OpenAI. I don't know about Claude, but in OpenAI it is like this. If you want to learn more about how to use AI in .NET applications, buy my course today. There is a link with a discount in the description of this video. Let me know what tutorial should be next. Thank you.